Did you know that there are multiple ways you can deploy wireless LAN environments? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
Hello, that's right. We are jumping right into designing WLAN deployments, and here to help us to understand why we need to do so, as well as what they are, Anthony Soquera. Anthony, as we get started here, okay, we might be thinking, Anthony, I've set up a wireless, at my home. Big deal. I just put another wireless access point up and we are ready to go. Why do we care about deployments here?
Yeah, great question, Ronnie. We are not talking about home environments today.
Okay.
Well, I suppose we could be, actually.
Right.
But the emphasis, remember, with Encore is on the enterprise. So what are we going to do? What options do we have to really do this at scale? So we are going to talk about all kinds of options that could include a smaller environment. So what I've prepared for us here is, first of all, we need to look at what are the primary concerns when we're thinking about the wireless LAN. And I do want to say, too, that this is not the only episode that we're going to do on wireless LANs in Encore. This is just one to kind of kick us off from a design perspective. And when we are thinking about how we're going to implement the wireless LAN, there's two primary concerns that we are going to have. In fact, I'm going to add a third. The first one would be, before we even get to the two that I have on screen for us, the first one really would be, are we going to be deploying a wireless LAN controller or not?
Okay.
We'll see that one of our models is a controllerless deployment.
Right.
So are we going to be using a wireless LAN controller or not? If we are going to be using a wireless LAN controller, I'm going to show you some great deployment models of how you could get that wireless LAN controller placed. And then the other thing that we need to think about is, and it very much hinges on that first point on the slide of the location of the wireless LAN controller, we need to think about the access point to the wireless LAN controller connectivity.
Right.
Because that's the big thing. When we start using the WLC, we need to make sure it has good, solid access to those access points that it's going to control.
All right, so let's jump right in and start talking about this question. So, Anthony, in what type of business environment would I actually say, hey, I need a wireless LAN controller?
Yeah, great question. So immediately when we start to scale and we have like different buildings that are part of our campus infrastructure and things of that nature, right when we get up to large numbers of users, what we call clients, and large numbers of devices, of access points. Mm-hmm. So the clients are those devices. It could be a user, but remember, it could be just some gadget that needs to get Wi-Fi access. As that number of clients increases and as the number of access points increase, you are really being pushed, if not shoved, into the wireless LAN controller arena so that you can more effectively manage all of those clients and those APs, those devices.
So according to what we've already seen here, you said that the placement of these things is actually a key. Why is that so important?
That is going to be a key. One of the reasons it's so important is, remember, we need to make sure that the access points can phone home, if you will, to that wireless LAN controller. So the placement of the WLC is going to be important. Also, your access to the wireless LAN controller as an administrator and latency issues. We'll see some examples of that here. So the placement becomes really important for those kind of reasons.
So how is this going to design when you talk about the placement of these? Is there a particular model that we need to address?
So I'm going to give everybody some simple to understand models here. And they're so straightforward, I probably won't make many flashcards in this area.
Right.
I'm making the flashcards as I have time. I'll do more today up on cram.com for our students. There won't be a lot here because watch how simple this is. The first model that we're going to discuss, Ronnie, is the distributed wireless LAN controller deployment. Distributed. we're going to take wireless LAN controllers and we're going to distribute them around our infrastructure as opposed to centralizing them. What are we doing? We're moving them closer to the access points that they control. And that's great because that makes it easier for the APs to communicate with the WLC. We need to make sure, of course, that we can get that access that we need to the wireless LAN controller to reconfigure things. But an often used paradigm here with the distributed deployment is that we take a wireless LAN controller and there's at least one per building. If we have this big campus with lots of different buildings, we're going to have these wireless LAN controllers connecting to distribution layer switches typically, and that's going to get them connectivity back to like the main campus where our IT staff is operating out of, and that ensures that they can get the access they need to the wireless LAN controllers. Now, I've got that great acronym here on screen as a reminder for everyone of how typically we are having the APs communicate with the wireless LAN controller, and it's CAPWAP. So we have those CAPWAP tunnels that are going to be established between the APs and the wireless LAN controllers. And when you use this distributed model, notice a huge benefit we're getting is the CAPWAP tunnels, they remain in that geographic location. They remain in that building because remember, those are the communication tunnels from the APs to their wireless LAN controller, and we really kind of segment those into the buildings where those WLCs are distributed to. Now, there is something to say you're running that, remember, we are really leaving budget out of this, right? It's like, oh yeah, we have the budget for this really high-end wireless LAN controller in that building, in that building, in that building, in that building. So we're assuming the budget is in place to do that type of an approach.
So with this distributed model, though, as well, are the buildings able to essentially be also managing like between each other, or do they are just independent?
Yeah, the buildings do have that kind of independence, and that's nice. But remember, we got to make sure that all of those wireless LAN controllers do connect to the distribution network, typically a distribution switch, so that we can easily get to all of them from our management of the WLCs.
So another way that we can actually do it then, if we said, look, it's not so much important that each building needs its own wireless LAN controller, but that we need one maybe centralized?
Yeah, so we might go with a centralized model. And by the way, I thought I drew it. I did draw the distributed one. Yeah, after, a few bullet points to discuss it. There's my incredible, I was really proud of this last night.
Very nice.
Yeah. I sent it to my wife for Valentine's Day. She wasn't really impressed for some reason. But so here you can see those green pizza boxes. Yeah. Those are the wireless LAN controllers. And by the way, it is important for us to recognize the official Cisco icons and note that when you look close, that might look like an AP, but there is a key distinction on those wireless LAN controllers. If you look at the top of the pizza box, you'll see the arrows, and those arrows on the top of that pizza box, those indicate that it's the wireless LAN controller. And Ronnie, there's our classic example where we're distributing those across different buildings. But to your point, there is a centralized model. So here we have multiple wireless LAN controllers, and certainly this might be just one, but to kind of keep in this same paradigm of the 3 buildings that make up our headquarters, notice we're taking those 3 wireless LAN controllers this time and we are centralizing them. This has a huge advantage as far as our management of the WLCs, right? We could make sure they're in a physically secured, data center location. We can take advantage of all of the data center stuff. Our great access. The wireless LAN controllers may be like in the next, server closet over from where I'm sitting. So we have this great ability to manage them. The big thing that we got to watch out for here and make sure we accommodate for is, where are the CapWAP tunnels now? Well, they're going from the buildings where those APs are distributed back to the centralized wireless LAN controllers. It's doable. It's not necessarily a problem. We just have to make sure that we are accommodating that tunneled communication back to the centralized brains of the operation.
So when would we choose instead something like the controllerless type?
Yeah, let's talk about that, because that is one of our big topics here. We, as we said, don't have to use wireless LAN controllers to take advantage of Cisco wireless networking, wireless LANs. Remember the language here. And this, I remember long ago when this technology was invented, I really struggled with these terms. So I don't want our students to have my struggles. There are two types of access points. There are autonomous access points and there's lightweight.
Right.
Now, what messed me up was when you think about those two terms, autonomous sounds way better
than lightweight.
Right. Don't think of it in human terms. Like, I want to be autonomous and I don't want to be a lightweight.
Right.
I don't want to go to the gym and be a lightweight,
right,
or being in an adult beverage drinking contest and be a lightweight. That'd be bad. So lightweight kind of had this negative connotation to me, and autonomous had a positive one. Well, reverse it. When you're talking about scalability, you want lightweight. Lightweight means the AP, sorry AP to insult you, but it's dumb. Mm-hmm. It needs a wireless LAN controller for the control plane intelligence to get the job done. So an autonomous access point is got the intelligence built in, so it's superior in that way, but it doesn't function with a wireless LAN controller. Mm-hmm. So it is not as scalable, as sophisticated a solution. So that makes, Ronnie's like, why did you ever struggle with that? That's easy, Anthony. No. But for whatever reason, the lightweight sounded bad to me, when actually the lightweight is the scalable way to go. Have the wireless LAN controller provide the brains. So here we can see a controllerless environment. And notice I put in parentheses autonomous. So those APs, they possess the intelligence that they need to have their control and data planes all built in them. And we don't have a wireless LAN controller in this non-lightweight environment. And if you look close at those APs that I had fun putting in the buildings, those are APs. They're not wireless LAN controllers.
Now, when we start talking about the centralized idea and the distributed idea, I know that the exam objectives also call out the idea of a cloud-based idea. So when we talk about cloud-based, what's the advantage of it? We kind of realize it's centralized, but what's the advantage of going to cloud-based?
This is really cool. So look at this. We are taking a virtualized wireless LAN controller and we're putting it in the cloud. Now, I always tend, and beat me up for this, I always tend, because I'm such an AWS and Google Cloud Platform nerd, I always tend to give those examples. So, all right, one of the advantages, Ronnie, is that we can put a wireless LAN controller virtualized into AWS, and we're going to save money because it's lower cost than buying the hardware. And Amazon Web Services is going to make sure that's always available for us. It's always going to be up. And this is so great. Just caution me, because remember, this could be private cloud.
Right.
So you could be doing this in your enterprise's private cloud. You don't have to do public cloud. And sometimes we get in that trap of public cloud, public cloud, public cloud. But this could all be controlled by us. But back to the AWS example, because I can't resist, and that's so much more common. So that is a wireless LAN controller that we get in the AWS marketplace, for example, and it is a virtualized WLC. It's there in the cloud. We have the APs in the buildings that are going to be managed by that cloud-based wireless LAN controller. And our big deal is to make sure we have VPN connections properly set up from those buildings to AWS so that that cloud-based WLC can do its CAPWAP with those devices and all that fun stuff.
Now, let's kind of go back now that we have a choice between either centralized or distributed. If I have a branch office somewhere, it doesn't seem like I can do any type of centralized environment, can I?
You really, you could with like an always on WAN circuit and all that stuff, but it's not all that common, to your point. What is often done is something I show here. This is the Flex Connect remote branch design.
Oh, okay.
Yeah. And what you're doing is, to your point, Ronnie, yeah, you have the wireless LAN controller at headquarters. You have this WAN link, and then you have your APs out at the remote branch, and Flex Connect is tuned. It's designed for this, and they do all this cool stuff behind the scenes to allow you some really decent scalability over. Look at the example I gave. So this is out of the Cisco official documentation. This is what we could do. We have a 640K WAN circuit. That's darn slow by many of our WAN circuit standards today. But even with this slow circuit, notice that we would have a round trip sustainable latency of 300 milliseconds. So what that's saying is this solution would work even if you have that kind of round trip latency.
Nice.
That's pretty high.
No.
And you could scale this to 50 APs out in the branch and 1,000 total clients. So for a very small WAN circuit, we end up with some pretty good scalability numbers thanks to that Flex Connect remote branch setup. The last thing, Ronnie, that we wanted to talk about was, and I'm going to give some more information on this in the show notes. So I'll shoot that over to Ronnie right when we're done. I wasn't going to do that, but it's a good idea. I'll send you in the show notes just what you would want if you need more information on this. But just remember that the Cisco solutions can do location services for you. So if you have like RFID chips on stuff that you want to track, these wireless LAN controller solutions from Cisco can do location services. It can use up to 4 channels in the 2.4 gigahertz band. And what you do is you have the RFID chip typically saying it's pre-programmed to be, okay, I'm going to be on channel 6. And then you go up to the wireless LAN controller and you say, okay, scan on channel 6 for those RFIDs and let us know where they are. It does a cool RSSI like measurement thing to plot where that thing is you're tracking.
That's pretty cool.
On a map. It's really cool. And then this is one of the main reasons I'm going to give you some show notes. There's the sophisticated probe request forwarding and some fancy stuff you can do with the Cisco client extensions to make the accuracy of that information even higher. And I'll give you all the details on that if it's something you need to take advantage of.
All right, Anthony. Well, thank you again for helping us to understand more about the idea of WLAN deployments here. We've actually talked about centralized as well as distributed controllerless versus controller-based as well. Cloud, you name it. We've covered several different options for us to make sure that we're familiar with the design options that we have available to us. But there is more CCNP Encore to come, but that is later for another show. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.